All right, so I have a super simple, just 2 rooms here made in trenchbroom with fun Godot. This is 4.3. This will work with any 4 version of Godot, and I have a simple character controller from the asset library. So before we do any of that, we're going to go into our trenchbroom game config folder that's within your Godot project. It doesn't matter, just where you have anything. And go ahead and put a folder called entities and create a new resource. You're going to want a Godot point class. A point class just spawns in a node, just like in trenchbroom. Doesn't affect any geometry or anything like that. In soundscape. All right. Mic here. Okay. So we're not going to make the script just yet. You don't need any of this. You don't need a scene file. Just go to entity definition. Soundscape. Yeah. Don't put a space in any of these little things right here. It'll mess up the formatting, and then you can just do ignore that. Go to class properties, and this is what we'll see these in trenchbroom, and then we can move them over into Godot. So for our sound, we're going to want an audio file to tell what actual MP3 or whatever you want to play, and we'll just make that a string, keep it empty. We're going to want a fade in time variable, so how quickly it should transition in and out or whatever. You can have a separate one for in and out. I keep it the same though. I'm just gonna make that a float and make it 0.3 or so. You're going to need a radius for the area. So we'll just make that an int just to keep things simple. And we're going to need a volume. Just if you want it louder, quieter, depending on the file, and it have. Let's do target. It's going to fade in the volume, so target volume is the last one you want. We can make that, I don't know. We'll keep that at 0 just for now. All right, now go down to node generation and make this a node 3D, because it's going to spawn in just a plain old node 3D as a start, and then later in the script we'll add in an audio stream player and an area. I don't know why that's, oh, okay, let's see why later. So now we need to put this into our FGD folder, so mine's tutorial FGD because that's what it's called. Go down to the entity definitions and drop in environment soundscape right here. Hit export and then go to your trenchbroom gain config file, which holds your FGD, and just export that as well. Now in trenchbroom, if you hit F6, you'll get this pop up in the Unity browser if you did everything right. And you'll see it has all of those properties we just put in there. Yeah, so good. And make sure in your Qodot map that you have Qodot makes you have to a little different than Qodot, then you have to put in into the FGG. It might not be the same. So just make sure it's in there. If we build this, you'll see all the. Why is it not showing up? Oh, let's say that. You'll see we have this spawned in where it was, where we placed it in the map. It doesn't do anything yet because we haven't set it to do anything. So let's fix that. Let's go into entities and create a new script. No, not a scene. I need a script. All right, and just call this, in escape. I'm going to go ahead and copy and paste these in. I'll have the code node paste bin or such, or whatever. Okay, so we have a tool modifier. This allows this function right here to work in the engine. What this does is that it allows the properties set by trenchbroom to work in the Qodot add-on to basically transfer them over seamlessly. Not exactly seamlessly, but you get what I'm saying. And so this will just give us a dictionary of the properties we have in trenchbroom, which will then give it to this dictionary we have set in the engine. And you can see here all of these just match the ones I set in the entity, and that's important because it'll just immediately transfer them all over. All right, here we have a couple more variables. Now, there are a lot of ways you could do a soundscape thing, but I just found this kind of works pretty well and I made it, so, We need a variable for our audio player node for when we add it to a screen, say the scene later, and we need that same variable for an area. The player target node will be useful for calculating the distance between us and the player, which we'll set later. For the check ray, check current frame, and is in sight are variables for when we time slice and make sure that a raycast can be shot from the environmental node to the player, and there's not like a wall or anything in between. You wouldn't want to like huddle up against a wall of another room and hear its soundscape while you're in another room, after all. Same thing with the distance player. Actually, we don't need this. This is just helping us determine the distance between us and the player target node. And then the fade tween for when we inevitably fade in the audio and fade out the audio by changing the volume. Okay, so now we have our ready function. This will assign a new audio stream player node to the audio player variable. We'll set its volume to -30. You could do it -100 or whatever. It's just to make it super quiet, just to make sure when you lerp or tween the volume later. And we add that to our node 3D, the node we're in right now. The audio player stream is right here set to, I have it to where it just goes into the trenchbroom folder and then this file called audio. You can make this whatever you want, but it's just so you don't have to type out the entire file path in trenchbroom, and you instead do right here, I would type in track 1 or track 2, just to make it a little simpler. The area trigger is assigned a new area 3D and is created. It is added to the scene. We then create a new collision shape. We set that shape to a new sphere shape. We set that sphere shape's radius to what we assigned in the properties to the radius. We then add that collision shape to the area trigger, and we then connect the area's both body entered signal and its body exited signal to these functions right here, int trigger and int leave. Whenever int get triggers get called, it checks if the body is in player. So with your player node, you're going to want to add it to a group called player. Make sure you do that. Then our check ray variable is assigned to true. Player target node is set to the body, and the player volume is just again set to volume -30. I don't actually think you need to do that. I did that for bug testing. Similarly, on int leave, the body, if the body is determined to be the player, it just stops checking the ray. Now let's get that line of sight figured out. So we have a function called check sight, and it takes in a variable which will be the player body node, basically. We use if check current frame, we immediately invert its value. So it's going to be a true or a false. This basically just checks it. It sets if it's true, it's a false, and it inverts it. Vice versa. If it is false, we just return the last variable. Whatever, we just return false, basically. So this way, we're going to be calling this function in physics process. So if our physics is running at 60 frames per second, this will only be checked 30 times a second. It'll save performance. You could even do this lower. You could try to get it down to like 15 frames per second or 12 if you really wanted to, but it's a static thing. I just did this. So now we make a space state variable. We get the area trigger, which is represented in 3D space. I just did that instead of the self. We get world 3D in its direct space state. We then create a new physics ray Curie parameters 3D with this. We set it to collide with area. We set it to collide with only bodies and not areas, just to make sure. We set its from position to the position of the area, the exact middle of it, not the sphere or whatever. We set its to position to whatever we design and designate the point to be, which will be the player. We then set the parameter to exclude itself, just so it doesn't accidentally collide with anything else, which it shouldn't happen anyways, because we said don't collide with areas, but just in case. We then make a result variable where we have the space state intersect array based on the parameters we set right here. If it collides with, if its collider, assuming it even is colliding, is the point which we wanted to see, it'll return true. If it isn't, it'll return false. So this way we can actually exactly tell if the player is in the sight of the environmental soundscape or if it's behind a wall or a shelf or whatever. You could even add its mask in here, the dot mask. Yeah, collision mask if you needed to mess with that, but this is a simple scene, so we're not going to do any of that. We'll now get the physics process all figured out. Before we do that, though, we need an auto load script. So, yeah, I have a folder right here. you'd have like a game manager thing. You would add this to this, but I don't have one anyway, so we're gonna create a new one. Just call this game. Yeah, there's nothing in here yet. We've got project, globals. Okay, we go to path, auto loads, game. I'm just gonna set it to game in all caps. This will be auto loaded and it's global, so any script can just attach, can attribute or receive any variables set in this, any function set in this, whatever. Okay, so in here we haven't had anything special yet. Well, all we have is the extension of the node, and we have two variables: var eligible soundscapes, which is an empty array, and current soundscape, which will be the only one. Current will be the one that is playing. Eligible will be any that the player is currently within. So if you have any of the areas from the soundscapes colliding or overlapping, you would get this weird effect to where it would loop through each one, fading in and out of each one because it'd be competing for which one is the dominant one. This will change it. We'll code this later, that it will only play the one the player is closest to, absolutely closest to, so you only have one playing and smoothly transitions. Let's go ahead and add the physics process back to our soundscape. Big hunk of code, what does all this mean? Alright, so let's start with this one right here. If check ray is enabled, so if the player is currently within the area, it will then run through our line of sight function, determine if there's nothing in between the soundscape or the player. If that's true, it will then go to take the autoload script and it'll add itself to the eligible soundscapes array. It'll append itself. Then, this is kind of jumping ahead, if the game current soundscape is the current soundscape designated by the autoload script, it will then check if the auto player is paused. If it is, it'll unpause it. If it's not paused and if it isn't playing, so if it was never played before, it'll then start playing it. And then down here, this is where it actually fades in the audio because it's set to -30 as we designated before. So if that's between whatever we said the target volume was, which it should be -30, it will then create a new tween, and we then use that tween to animate the fade in the property of the volume. We take the audio player variable, it's a volume in decibels. We then lerp that to the target volume based on the fade time that we also set in the properties, and I just did it to translinear. You could do it Bezier or however you say that word. I don't know. I'm not French. Up here, this is assuming. Up here, this is actually important. If the player target node has been designated, which in int trigger it does, it will then calculate the distance to the player and store that in a variable that we will use later. So it just does a simple distance to player target from the area. If the audio player is playing, and this is assuming that we've already left the node, so we had to transition to another one. If the audio player is playing, if this current soundscape is not the soundscape we're in, the player is in, it will then create another tween. It'll do the same thing except fade the volume out to -30 based on the fade time. It will then await whenever that tween is finished, and then it will pause the stream. You could have it stop. I preferred to have the ambience pick up where it left off, though. I just think that sounds a little better. And if you have actual music, I think it keeps the... well, it depends on the song, but that's not important. Whatever. You'll figure it out. Okay, so back in the audio load script, let's get that algorithm to... well, not really an algorithm. That's kind of big brain speak, but we'll get that to determine the closest one to the player. Okay, so in this physics process, hold on. Actually, this should probably be done. There, no point creating a empty array. Okay, so it'll first check if any eligible soundscapes exist. If there is at least one in the array, it'll run this code. It now creates another empty array, and I just have it called D. We then loop through the eligible soundscapes array, 4x in range, eligible soundscapes, dot size -1, because arrays start at 0. If the eligible soundscape that we just did calculate the distance to player, which at this point it should, this is just a simple check if you run really fast or whatever for some reason, it will then store that distance to player in a variable. This is A. It will then add that said distance stored in this variable to D, the empty array we create up here. It'll just append that. and loop through that, however many instances there are. It will then sort D from least to greatest. So we have the least amount of distance to the greatest amount of distance. We then loop through D, the distances, for how many instances it has. If D0, so that's the first index in the array, which would be the smallest, the shortest distance, is equal to whatever the same number is in the eligible soundscape. So that just is attaching, that's just comparing the soundscape's distance to itself, basically, just with two different arrays. If that is true, it will then set the eligible soundscape with the least amount of distance between the player to the current soundscape. So that, I know that's a mouthful, but this basically just keeps the system running and not having two playing at once or fading into each other. Let's go back to trenchbroom. Run F. Well, actually, hold on. Before you do that, you need to attach the soundscape script to the soundscape entity. So back with the script class, you just drag in this, save that, go to your FGD, export that, and your trenchbroom game config, and export that. Save here. If you run F6, now nothing's really changed because that's all we did was attach the script, which you can't alter from trenchbroom, but it changed. So with this one, we'll put this close enough to the middle of the room, and we'll make it track1.mp3, or whatever your audio file is. Well, I'm just going to duplicate this, and let me do that. Duplicate this and make this track 2. So that's track 1. This is track 2. Go ahead and save that, and go build your map again. You notice there too, when they have their script attached, you can attach from here. Check their dictionary. Has their chain? It's changed because they're not empty. Now you'll notice that they don't have any of that stuff attached to them because we haven't ran the game yet, because we didn't run any of that in like a tool script. We ran this can run at the inside the engine because of the tool script, but none of that other stuff can. But if we run the game, well, for one, you'll hear the music. Yeah. Here and one. And now the other one's playing. Check the remotes. It's what's actually in the game right now. They'll have all their nodes because we ran that just on ready. But also notice, I get up to this wall, it'll still fade, even if we set the node to like a ridiculous, like if we made this, what if we made its radius like 100? So at this point, it's like enveloping the room like a, yeah, you know. If we build this, okay, still the same music, but we get closer because this is the closer one. It'll still play whatever the room is supposed to be, although you would never have your soundscape be massive or whatever. And this is just a simple area-based one. You could also have them set up by triggers. You know, if you wanted a funk brush and then set the target name, but I'll talk about that in another tutorial.